So today's presentation is really around how do you scale out your VMware environments. We'll talk about a number of challenges that are faced in scaling out a VMware environment. Some of the things that we'll talk about include storage and availability concerns, disaster recovery concerns, and some of the challenges that you'll face in virtual desktop as you scale out. So we will be focusing on the challenges you may not be aware of because you may be in small environments today, which we hear, and also some of the challenges that you may be facing today as you already have large environments and there's some things happening that you're not too happy about. Some of the things that we won't be touching on that are important in scale-out environments are compliance, right? Configuration management, making sure that the right applications are provisioned into your environment. We will not necessarily be touching on security, even though Symantec is a security company. Has a lot of security, but we have a big focus on storage and availability, and so that's what this is about. We will not be focusing primarily on the backup side of things, but we can talk about how backup is important and how that actually becomes more of a challenge in a scale-out environment. But we will focus on these things. So the first thing that I want to talk about is storage. And the thing that I want to talk about really is SAN versus NAS. And some of you may be looking at much smaller environments where you actually have direct attached storage or local storage. So as you start to scale out your VMware environment, what you'll find is that there are all kinds of challenges that come from having either SAN or NAS. SAN and NAS solve different problems in the VMware environment. Different problems whether you're in a VMware server environment or a virtual desktop environment. And the debate continues, right? So each of them have different pros and cons, and each of them are chosen for different purposes. We all are familiar with what SAN and NAS are, right? That's good. So SAN primarily is chosen for high-performance applications. Think of databases, think of high transactional applications that need direct connectivity to storage that are doing a lot of IOPS. When that happens, we tend to see customers move towards SAN. And traditionally, we see customers staying in a SAN environment where they were in a physical environment before. They had a high transaction workload application. They're moving into a virtual environment. They want to maintain that performance level. They don't want to go through VMFS. They don't necessarily want to go over a network because they have concerns about the performance and latency of a network provides. So they stay in a SAN environment. Okay? That brings up a second point. The point is not listed there, but another reason why end users tend to use SAN when they move from physical to virtual is that it actually makes the migration from physical to virtual fairly straightforward. So if I used to boot off of a SAN device, I can continue to use that SAN device with raw device mapping in a virtual environment. It makes that migration seamless. If I want to go back, I can do the same thing. So I can migrate from my virtual environment back to my physical environment if I decide that that's what I want to do and that I'm not actually happy with the performance that I'm getting in my virtual environment with SAN. So another reason why people use SAN is for mission-critical applications. So how many of you have mission-critical applications today running in your VMware environment? Yeah. And how many of those are running on SAN? So what was your purpose for running mission-critical applications on SAN? Anyone? Availability. So help me understand that. What do you mean by availability? So SAN provides you that level of availability? Okay. And how do you keep those applications up, running 24/7? Okay. Okay. And then you also had a mission-critical application. So why did you choose SAN? So clustering, for clustering purposes. Now, that's actually a great point. And one of the reasons why people use SAN is they have used traditionally in the physical environment OS-based or guest-based clustering technologies. And a lot of those require raw device mapping, physical mode, and therefore SAN makes a lot of sense. However, that carries with it some cons as well. So if you're using raw device mapping and you're using OS-based clustering, what you'll find is that things like vMotion, DRS don't work. Right? You no longer have the mobility that you can get, that you would get otherwise. That's advertised by, we listened to Paul this morning. He talks about the third phase in virtualization is really around this agility, right? And so that agility part becomes difficult to achieve when you have OS-based guest clustering. Okay? So that's one of the problems that people face. Now, people are willing to make that trade-off because they need those levels of high availability. And so they say, okay, I need a level, an SLA, which is 5 nines or 7 nines. And the only way that I'm going to get that is with something that actually can provide me assurance that it's going to monitor my applications and bring them back up online in the event that they go down. One of the other cons about with SAN storage is that it tends to be very expensive. So if you look at SAN environments, how many people here have more than 10 VMs in their environment? How many more than 100? More than 500? More than 1,000? More than 2,000? Okay. How many do you have? Over 10,000. And are you guys SAN-based or NAS-based? Most of them are NAS-based. So if you think about it, 10,000 servers on SAN. And we were having a conversation earlier, and you're saying that the boot devices that you guys are provisioning is about 30 gigabytes per OS image. We're talking about 10,000 times 30 gigabytes. And at a cost of about $3 per gigabyte, if that's what you have on your SAN environment, that gets pretty pricey pretty quick. You multiply it by 3, by 10,000, by 30. You're starting to look into the millions of dollars range. Okay? So SAN gets pretty expensive. And of course, as you add a number of VMs, you have to add infrastructure, SAN infrastructure, to actually support those VMs. It means more switches, more SAN fabric, more zoning that's required. So if you think about it, with 10,000 VMs, if they were basically all provided over SAN, I'd have to zone to all 10,000 of those VMs from my LUNs, from my array. Yes? It should. So are you seeing deduplication in the SAN environment? Where we're seeing deduplication the most is we're seeing it mostly in the NAS environment.
Yeah, we're just starting to look into it NAS before. I was just wondering if it would be applicable in the SAN environment too as well.
So we haven't seen it yet in the wild. I think it's pretty tough in a SAN environment because you really have to define across what domain are you actually doing deduplication, right? So am I deduplicating across this group of LUNs that I've defined as being some sort of deduplication set? That sort of mechanism is not really prevalent in the wild. We haven't seen it. But it actually makes a lot more sense in a NAS environment because what you have is on top of your storage, you actually have a file level abstraction. And in that file level abstraction, you have files. Now, that actually defines a set, a working set, that I can actually now go and do my deduplication. Okay? And so that brings me to my next point, which is, what are some of the reasons why someone would choose NAS? And it's exactly that. As I'm trying to drive my storage costs down, one of the things or one of the tactics that I can employ is deduplication. Not only deduplication, but compression, right? On top of that, there's additional techniques like cloning, right? So if I have an OS image, you have a 30 gigabyte or 40 gigabyte image, and that image is used over and over and over again. It's a Windows 2008 R2 image. I want to release that or make multiple copies of that. I can clone it. And when I clone it, what I'm going to do is not take an exact copy of that 40 gigabytes multiple times. Instead, what I'll do is I'll take that 40 gigabyte image, and then I'll take the deltas that each of those additional boot images require, and I'll store that. So cloning, deduplication, and compression are all some of the cost-saving techniques that can be achieved with NAS. Okay? When we look at some of the benefits that you can get by doing deduplication and cloning in a NAS environment, we're seeing upwards of 85% of the data in an OS image, in a VMDK image, is actually duplicated data. That's what we see in our labs. We were just at another session by a filer provider who is actually showing around 80% duplicate data. Now, this is ideal for VDI environments. We saw Paul talk about it this morning. You look at virtual desktop environments. Virtual desktop is expanding, is beyond just the PC, beyond just the thumb terminal, but even into mobile devices. Yesterday, I was in the red truck in the back of the booth area over there, the exhibition hall. And what I saw was a virtual desktop running on an iPad. Okay? Now, if you think about that, I'm not going to run SAN to my iPad. There's no way, right? It doesn't make any sense that I'm going to actually have Symmetrix LUNs zoned into my iPad. Okay? I could, however, run NFS to my iPad. That makes a lot of sense. So network connectivity, data over network, makes a lot more sense in a VDI environment. I'll talk a little bit more about VDI later. Now, one of the problems is that you see in an NFS environment, or network environment, is eliminating bottlenecks becomes quite difficult. So why is that? Think about some of the traditional NAS solutions in the market today. Okay? The traditional NAS solutions in the market today, monolithic filer, 2 controllers. Okay? Now, what happens when you saturate those 2 controllers? Your performance goes down. How do you boost your performance? Add cache, right? Or add more. Buy another filer. Buy something, right? So it's either you're buying cache, and we've seen people do that. So if we look at virtual desktop environments, what we see is that with the filers, when they hit about 500 virtual desktops out of some of the common NFS filers that are out there, they start to saturate. And we've seen people be able to actually throw cache into the controllers and be able to double that. That's great, but then you only have 2 controllers that you can actually get the benefits of shared cache across. So what happens then, right? So it becomes difficult. Now, if you're using SAN, you can solve this problem pretty easily, right? If you have a bottleneck, well, you just stripe across more LUNs. Now, traditional filers face a couple of other problems, and we'll talk about those in more detail later as we start to talk about the virtual desktop environment, because that's primarily being built on top of network-attached storage. And that is that for a small number of VMs, it actually is very expensive. You think about the cost of a filer. You guys know what the cost of a filer is? Any guess? Just for like a mid-range filer? Yeah, 50 plus K. We're probably looking at closer to about 70K, right? And so if I'm running my 50 VMs on 70K worth of hardware, that's a pretty expensive proposition. Now, what we hear is that the typical cost allocation for a virtual machine that comes from storage is about 38%. And there's no way that you're going to get that kind. It's actually going to be closer to 80 or 90% if you're running small environments on filers. When you start to run large environments on filers, you run into the exact opposite problem. The opposite problem is we talked about the saturation issues, right? And when you start to saturate those filers, then you're going to look at things like putting flash into your filers. You're going to look at things like dropping more filers into your environment. And what that's going to mean essentially is that, well, my costs now start to go up and my cost of managing my environment becomes difficult. We're talking about how do you scale your operations, right? Not so much how do you scale the cost of storage. Storage is no longer the problem here. So let's look at some industry trends. These are some industry trends that show, from EMC, one of the VPs at EMC says that today about 70% of the virtual machines are actually on SAN. Okay, and to a large extent, I think that's because SAN has been prevalent in the data centers, right? It's been prevalent for some time. People are familiar with SAN. They have SAN infrastructure, and it makes a lot of sense, as I mentioned earlier, to easily migrate my x86 environment into a virtual environment with the infrastructure I already have. There's also questions around performance. So we see concerns that come up around what is the performance that NAS can provide. And some of that is actually changing. The thing about NAS is that it's very simple to add data stores. So with NFS, there's no such thing as LUN management, right? You don't have to worry about LUN management. Instead, you create a large file share, and as you need to create new virtual machines, you simply create new VMDK files in that file share. The other thing about NFS that's an advantage that's actually, and this is reflected in one of these quotes up here, is that if you look at traditional VMware environments, 2 terabytes is the limit of the size of a LUN that goes through VMFS. So if I'm going to use SAN, I'm basically limited to 2 terabyte LUNs. Okay? If I use NFS, we actually bypass the VMFS layer completely. So VMDKs that are picked up over NFS actually bypass VMFS. VMDKs that are picked up in an ESX host are bypassing VMFS, and that can be of any size. So you can bypass that 2 terabyte limit. So if you're looking at creating LUNs or data stores which are larger than 2 terabytes in size, this is one way to do it. Okay? So over time, NAS is going to be a bigger player, and that's coming from the CTO of VM Powered. And we talked about earlier that one of the concerns and one of the things that actually is that people have traditionally shied away from NAS is really the performance. But as 10 gig E continues to take off and continues to become more prevalent in the environment, we're seeing that some of that performance issues are actually going away. And we've had large investment banks come and tell us that they can get better performance over 10 gig interconnects than they can get over 4 gig fiber channel. Right? So when you start to think about that, when you start to aggregate 10 gig links together, you start to see a lot of massive performance. So VMware and NFS, why NFS? You would choose NFS because it's simple, it's inexpensive, it's incredibly flexible and storage agnostic, right? So NFS is a protocol. It doesn't matter what storage provider you use, NFS will work. It's high performance. High performance because of advanced locking technology. Again, the 10 gig E is actually driving performance in NFS environments. Support for jumbo frames. All of these things are actually showing us that, and again, as I talk to customers, and I talk to a lot of customers, spend a lot of time in the field, we're starting to see that there's no longer a concern around 10 gig E providing the performance that's necessary for their VMware environments. Now, it leverages the best of VMware. So VMware VMs run with low overhead and high speed. Intelligent NAS solutions allow you to manage your storage more efficiently. So to your point, deduplication, compression, cloning, all of these things can be done really well in an NFS environment. Yes?
One thing that when I was looking into deduplication, we've got an engagement customer now. Deduplication would actually reduce your bandwidth on your backup. We actually do the specking for day-to-day operation. It's like it actually reduces between 3 to 500%. Is that true, or is that just for?
Well, deduplication, so it depends on where you're doing your backup. So where are you doing your backup? Are you doing it in the virtual machine itself, or are you doing it from the storage device? So from the storage device, actually, you could be looking at 4x, 5x. Because if we're looking at, if we're saying that virtual machine OS images compress down or dedupe away around 80% shared storage, then 4 out of 5 bytes essentially are duplicate. Right? Now, what's important is it's important to actually have a backup solution which can either handle the deduplicated data from the array or from the storage side, or is capable of actually doing deduplication itself, right? And in that case, if it actually was to access a storage array or either a filer that had duplicated data, it wouldn't have to do much, right? It would do whatever additional deduplication was necessary, and then use that compressed stream to actually do its backups. Right? So I think the answer, I very much believe the answer is yes. I believe it depends on where you're doing your backup from. And so the suggestion here is that as you start to scale up your solution, one of the things you're going to want to look for is backup solutions that are actually integrated with the storage, whatever storage backend you have. Correct. Absolutely. That's correct. Now, I should call out that Symantec has net backup. I didn't want to make it a completely, Symantec pitch section, but of course, thank you for that springboard. So SAN has an advantage in terms of throughput, although we're seeing that advantage is actually degrading over time. But in terms of flexibility and management, NFS is much better. So to sum it up, some of the problems in virtualization, some of the storage problems in a virtualization environment relate to two things really. One of them on the left-hand side here is really around cost. And the one on the right-hand side is really around performance. Okay? So on the left-hand side, we see that lots of virtual machines can equate to lots of storage. So choose a storage solution as you're looking at scaling your VMware environment that's going to allow you to keep those storage costs low, the storage consumption low, as you grow into more and more virtual machines. And the sprawl of virtual machines is superseded by the sprawl of storage. And that's an interesting observation, is that as we look into our customer base, what we're seeing is that when you double the number of virtual machines, you actually more than double the amount of storage that's associated with it. Okay? That's because, one, you require more OS images. Those OS images grow over time as they're patched. On top of that, there's additional storage that's required specifically for the SX host, the SX host swap file. Okay? So you're looking at 2.5x maybe every time that you 2x the number of virtual machines. And that grows over time. A lot of people deploy technologies like thin provisioning. So we're all familiar with what thin provisioning is, okay? In order to solve this problem. And thin provisioning is a great solution to this problem. It allows you to actually grow and scale your infrastructure as business demands require. The problem with thin provisioning is that the benefits of thin provisioning actually erode over time. So we were having a conversation earlier. If you look at a Windows environment, the way that NTFS works, it actually scatters reads and writes actually across the entire volume. So if you have a partition, you could very well end up with I/O to blocks all the way at the end of the partition, even though the entire file system is not full. And what that does in a thin provision environment is it has a tendency to actually use up and allocate all of the blocks in a thin provision array. Over time, those blocks move around. They might be deleted. they may no longer be in use. The thin provision array has no concept that that's happened. So what you should also look for is a solution which provides a level of thin reclamation. Now, VMware is building that into their solutions, but the storage backend has to be able to handle that. So the various storage solutions that can actually handle reclamation requests or issue reclamation requests themselves. So if something like a filer that has the intelligence of what's being used and what's not being used in a file system can then go and issue a reclamation. The other thing I want to talk about was performance. So when you're sizing your environment and you think about, basically how much power do I have to put down both from the compute side and from the storage side, what you have to take into account is on the compute side and actually on the storage side, they both make sense, is that the I/O patterns change. And they're not all, if you look at the average I/O pattern over time and you look at the burstiness over time, what you'll find is that you really should actually look at your VM environment over the course of a couple of days to see what your peak load is. It's just like a utility. So if I'm a power company, I have to build my power plant to actually manage peak load, right? I can't build it to manage average load because that means that 50% of the time I'm actually not going to be able to service the requests of my users. Or there will be degradation in performance that is unacceptable. Okay. The second problem, and this is kind of a corollary to that, is if you look at that and you talk about, well, I have to size to this peak load, some of the peak load that's generated in VMware environments, and particularly from the storage perspective, come from what we call boot storms. Okay? Boot storms and antivirus storms, yes?
I'm looking at the mass as far as this whole thing around IOPS. So that you just give me 30 IOPS or whatever. But as far as caching help with the additional on boot storming and then your weak point for your network, or is that because of how many controllers you have at the top?
The problem actually is driven up into the network when you start to use cache. Okay? Now, so cache is a great way to get around this problem. The boot storm problem is really this. Everyone comes into work at 9 o'clock in the morning. They all launch their VDI at the same time. Or, this exact problem that we discussed earlier, is that you update your virus definitions, and all of a sudden a virus scan runs, and now all of the OS binaries have to be scanned at the same time, and that essentially brings your storage to its knees. So preloading into cache is a good way to do that. It's a good way to solve that problem. And the problem that we were discussing earlier, and actually I'll come exactly to that point, is that in John's environment, basically what he has SAN. Okay, and he basically updates his antivirus definitions, and when they go and do an antivirus scan, all of a sudden the performance drops, and that's because as I'm scanning my 300 virtual machines, I cannot get the benefits of SAN cache. Because every virtual machine essentially lives in different blocks in my SAN. And the SAN has no concept that this virtual machine pretty much has the exact same binaries as that virtual machine. Now, pre-populating your cache in that environment would work if you had enough cache to actually support 300 virtual machines in your SAN. That's a whole lot of cache. Okay? And the reality is you probably don't have that. In a NAS environment, it actually makes a lot more sense because what happens in a NAS environment is if you have an intelligent storage solution that can figure out that 80% of your boot images are actually the same data over and over again, then the first time that you scan your OS image, it's brought into cache. The second time that you scan, or the second guess that you scan, no longer has to go to disk, right? Because we know that those bytes are actually the same bytes that are shared between two VMDKs. At that point, it can come directly out of cache. And the analogy that I gave was, if I'm reading something out of RAM, it's like me walking to that door. If I'm reading something over the network, it's like me walking probably to the San Francisco Zoo, right, or Ocean Beach. Me reading something off of disk, I have to basically walk to Florida. Okay, the latencies, the seek times, are just that much higher. So that's really the storage side of things. Sorry, go ahead. So Symantec is a partner in vShield. It used to be called vSafe API, right? And now it's vShield. Symantec is one of the partners that's listed, and we are building solutions that can take advantage of the vShield API so that you can offload your antivirus to off-host of some sort. Okay. So the second point that I want to talk about is, if we look at what's driving scale, some of what's driving scale is you just have new applications coming online. Okay, so you have new applications coming online. That's causing your number of virtual machines, number of VDI to grow. Another thing that's actually driving scale, and a lot of this comes from from virtualization goals. So as I talk to customers around the world, there's a large logistics firm, you've probably all heard of them, but I'm not going to name the name. They have a 100% virtualization goal. Okay, what that means is they want to move every single x86 server that they have into a virtualized environment. One of the top 10 banks is now issuing or building out a virtual environment with 20,000 VM servers. They're also building out a sister environment with 20,000 VDIs. Those are huge. So as you're moving towards that virtualization goal, 100%, what you'll find is that the low-hanging fruit are easy to virtualize. Print servers, file servers, pretty straightforward. Virtualize them. They're actually the first thing that go into a virtual environment. The next thing that goes into a virtual environment are targeted solutions, things like very specific applications, which I'm going to go and put guest-based HA into, like Microsoft Cluster Server, or from Veritas, we have the Veritas Cluster Server. It's a Symantec product that can provide you high availability for your applications that you want to move into a virtual machine infrastructure. Now, the problem, as we mentioned earlier, is that becomes somewhat restrictive. So if we're looking at that third phase of virtualization, agility, some of these actually limit agility because you cannot do vMotion anymore. You cannot do DRS. There's a number of things that are no longer possible as you start to move into virtual infrastructure with OS-based clustering. So as we look at, as I mentioned, if we look at the criticality of applications, Tier 3 and Tier 2 applications are going to be the first that actually move into virtual environment. Tier 1 applications are going to take some time. And when I talk to end users, they typically tell me that the Tier 1 applications are remaining on physical for the time being. Test and dev, sure, those will go into virtualized environments. Print servers, file servers, those will go into virtual environments. And as we talk to our end users, actually, if we look at IDC, we see that we are in agreement with what IDC says. The number one concern that people have around moving Tier 1 applications into virtual environments is really around ensuring availability, making sure that those applications are up. Now, VMware has a solution for that. So VMware has two solutions to that, actually. One is VMware HA. The other one is VMware Fault Tolerant. Fault Tolerant is interesting, but Fault Tolerant, what it does is essentially runs a mirror image of your virtual machine on other hardware. That's great if you have a hardware failure. So if my motherboard goes, then the virtual machine can continue running on a second host. Not so great if their OS actually crashes or blue screens, or if the application crashes or blue screens, because what you're going to get is you're going to get two mirror crashes, two mirror blue screens happening at the same time, and your application goes down and you experience downtime. Okay? So how do you recover from that? And the way that you recover from that, traditionally, or as we talk to end users, is using VMware HA. VMware HA is a free component of VMware Enterprise. If you have VMware Enterprise in place, you can turn on VMware HA. It'll heartbeat the ESX host. It'll heartbeat the virtual machine itself. It'll determine whether or not they're alive, and if they're not alive, it'll restart it somewhere else. Okay? That's great, except it has one minor flaw. Is that somewhat 30-40% of the time, when you have a failure in your environment, it's actually not the OS. It's actually not the virtual machine. It's not the hardware itself. It's actually the application. The application either hung or the application crashed. And in this case, VMware HA actually has no clue that that's happened. So is that a concern for any of you? How many of you use VMware HA today? So pretty much everyone. So one of the products that we announced, and we actually had a session on this, we'll have another session on this tomorrow, at VMworld here today from Symantec, is a product called Application HA. It's a product that we co-developed with VMware. VMware actually asked us to go and develop this product. Interestingly enough, I've seen VMware guys go and talk about it in their sessions. And what it does is, if you look at VMware HA today, VMware HA really protects the hardware. It protects the virtual machines and the ESX infrastructure. What it doesn't protect is the applications. If you look at the applications, we protect the applications. So now VMware HA has a provision to actually go in and protect the applications. Now, how does this fit back into scale? So let me relate this back to scale, because the purpose of this presentation is to talk about scale. So as you're scaling up your VMware environment, if you look at traditional clustering, we talked about some folks who are doing traditional clustering today, they require 2 virtual machines at the very minimum. 1 virtual machine for the application, 1 virtual machine as a failover, okay? So the question becomes, if you have 300 virtual machines with mission-critical applications or applications that can't experience downtime, how many VMs do you want in your environment, 600 or 300? Okay? What I can provide you here is a solution that gives you actually 300 virtual machines, because if the application goes down, we'll bring it back up. And if we can't bring it back up, we'll ask ESX to actually start the virtual machine over again. Okay? So you don't need a standby virtual machine in this case. And you can still provide application-level clustering, something you couldn't do with, say, Microsoft Cluster Server. Okay? Great question. So what applications are supported? I think it depends on whether you're Windows or Linux. Initially, we're supporting the major applications, Exchange, SAP, IIS, Oracle. Over time, we'll add more applications. So if they're Exchange 2010. Savine, are we supporting Exchange 2010? Yes. The answer is yes. We are supporting Exchange 2010. It's great question. Is it compatible with SRM? So there's no exact linkage with SRM today. SRM is essentially, we'll bring down the VMs and bring them up at the other side. There's nothing that this does specifically around SRM. However, one of the things that this does do, once the virtual machine comes up, it makes sure that the application starts. One of the things that SRM does not do is if you actually use SRM to fail virtual machines from one site to another site, it can ensure that the virtual machines come up, and it can actually you can actually have tiers to ensure that they come up in a certain order. But what you can't do is you can't say that, okay, once the virtual machines come up, ensure that the applications came up as well. Okay, so SRM doesn't do that. If you have this installed, it will do that. So that's the integration that we have today. We'll have further integration in the future with SRM. Okay, so in order to do things like multi-tier failover and whatnot. Today, there are ways to actually go in and mess with so this is based on the Veritas Cluster Server Agent framework. There are ways, if you're familiar with the Veritas Cluster Server, to go in and have it actually genericized so it can actually monitor and start and stop any application, not just the applications that we support. Of course, we'll probably make that easier in the future, and we'll continue to add applications over time. One of the other nice things about this is if you're a VMware administrator today, and think about scaling your environment, okay? Think about the 10,000 virtual machine environment, okay? In 10,000 virtual machines, how do I figure out what's running where? If I go to vCenter, I have no clue. That becomes an operational nightmare. With this plugin, now the plugin is actually able to communicate back to vCenter and tell vCenter within an actual virtual machine what application is running. So now I can click on the virtual machine itself and see the application that's running. I can start or stop the application depending on whether I have that level of access control. That gives me a much better way of managing large-scale infrastructure. If I have 4 virtual machines, it's probably not an issue, because you probably know what those 4 virtual machines are doing. If I have 100, it becomes a problem. If I have 500, it's a big problem. Okay? So this helps us solve that problem. What's running where? So any other questions about this one? So there's an agent that's installed in the VMs. The way that the installation here works is, first you'll run and you'll install the application HA plugin just like you would install, for example, an SRM server. You create an application HA server, which can be in a virtual machine, hopefully not on the same one that your vCenter is. Then what you would do is you'll run the installer again, and you'll point it at which virtual machines you want to install the agents into. It'll push the agents into those virtual machines, detect which applications are running that it knows about, the ones that I listed, and over time, obviously, that'll increase. And it'll say, okay, do you want me to actually configure to protect that application? You say yes. It pushes the agents, it configures it automatically, and when it's done, it's done. That's it. So it's a 2-step install. First, install the plugin, into your application HA server that controls all of application HA, then push the actual agent into whatever virtual machines you want to protect. Simple as that. Answer your question? Okay, great. So the next extension of HA is really DR, right? So now as we're looking at providing high availability for large environments, how do we provide disaster recovery for high environments, for large environments? And providing disaster recovery, there's a couple of things that you really have to make sure that you're addressing. A number of challenges. Number one is obviously minimizing downtime. So what is my RTO, right? My recovery time objective. Also, what is my RPO? How much data can I lose? So reducing risk in a DR environment is also important. So how do I make sure that my DR environment is actually going to work? In the event that I have a DR, do I know that my processes are going to be able to start at the recovery site? Can I test it? And can I test it non-disruptively? And SRM has capabilities to doing that. And controlling costs. So doing all of this in a low-cost manner. So it leads to a number of possibilities. From the DR perspective, do I choose SRM as my DR platform? Do I choose guest-based HADR solutions, or do I choose metro clustering? Now, how many people here are familiar with what metro clustering is? No? Okay, so I'll go into a little bit of what metro clustering is, because it's a pretty interesting tactic to actually providing really high availability, fast failover solutions for disaster recovery. And of course, disaster recovery is impossible without replication. So if I'm going to actually bring my applications up at a disaster recovery site, or in the cloud, if your cloud is your disaster recovery site, I need to get my data there somehow. There's a number of solutions that can be selected for doing disaster recovery. You can do array-based replication to replicate data from your array to another array at a recovery site. Periodic replication will replicate your data every so often by taking snapshots. And there's host-based replication. Now, host-based replication can be any one of the top three. It can be synchronous, it can be asynchronous, and it can actually use periodic methods. So earlier today, I went to a session. VMware is announcing that they will provide their own host-based replication solution. It will be based on periodic. So what it means is that every so often, it will take a snapshot of your environment, and it will actually send the changes between the last snapshot and the current snapshot. That's their host-based replication. Other replication techniques can be deployed in the host as well. Symantec has one called the Veritas Volume Replicator. That one can actually do array-based replication, or not array-based, but synchronous and asynchronous-based replication. Now, when would you use synchronous and when would you use asynchronous? We'll talk about that in a moment as well. So when deciding which disaster recovery mechanism to use, you have to consider a couple of things. As you're scaling out your environment, let's say you go into 100, 200, 500 VMs, or even 1,000 VMs, SRM sounds great, but SRM has some challenges. Any idea how long it would take to actually recover an environment with SRM with 1,000 VMs? Okay, a long time, because a couple things have to happen. First of all, you have to stop your replication and bring your storage online at the DR site. Next thing is that you have to decide how your virtual machines are actually going to restart. Are they going to restart serially, or are they going to restart in parallel? Well, for mission-critical applications, they have to start serially. And what that means is that your virtual machines will start one at a time. Now, if it takes 2 minutes to 5 minutes for a virtual machine to start, and you have 1,000 VMs, you're not going to hit your 4-hour RTO. Okay? So what people do is they start to get creative, and they create tranches. And they say, okay, well, I'll create one protection group, and I'll put all my lowest tier or most important virtual machines into that protection group. They may not even be related. It could be a database for some application, a database for another application, but those databases need to start first. Then they'll create another, and then those will be started in parallel, not serially, but in parallel. Then they'll create another replication group above that create the next level of applications, even though they may not be related. They may be related to something in the first protection group, and they'll start one level at a time, each of the protection groups. Does that make sense? Well, I'm going to have tons of protection groups. It's going to be interesting to manage which applications and which virtual machines do I put into which protection group, right? So another method to solve this problem is to use guest-based DR. These are DR solutions that actually run in the operating system. They monitor the applications, they monitor the replication, they control the replication, and bring the applications online at the DR site. Now, because these are independent, and because these focus on a specific set of applications that provide a service or solution, they can start those applications independently of each other and in parallel. So if you're looking at a large number of applications and you need them to start within a short amount of time, your RTO is, let's say, 4 hours, and you have 1,000 VMs, you might start to look at guest-based solutions in order to start those applications in parallel for each of the actual services that you have within your data center. And the last thing is Metro Cluster. And by the way, Metro Cluster and guest-based DR, Symantec has solutions for that. Veritas Cluster Server does this. If you're interested, you should look it up, see what it is. Metro Cluster is is stretching your SAN across 2 data centers. And we see customers do this because when you do this, you can actually get 1-minute recovery times. And your recovery point objective becomes 0. So if I have 2 data centers that are within 100 kilometers of each other and I have dark fiber between those data centers, I can actually stretch my SAN and I can mirror my data between the 2 data centers. If I have 2 VMs that are in a cluster, now what I have is essentially the same as a guest-based cluster that you would have in a single data center with a HA solution, except now it's stretched across 2 data centers, so you get a combined HA and DR solution. So there's no SRDF, there's no replication of SAN. What it is that if you have DWDM links between your 2 data centers, dark fiber, okay, you essentially present LUNs from an array at one data center to a host at the primary data center. And when it does I/O, it actually does I/O simultaneously to the LUNs at both data centers. So there's no replication taking place. It's just like a mirror. You do a mirror, except instead of doing it at the array, it's done from the host. And at that point, when data is actually completely synchronized between the 2 data centers, if you get a data center loss, you can actually recover instantaneously at your secondary data center. Correct. So you're mirroring, basically. Now, it requires twice the storage. Correct. And now, which replication technology do I use? So, look, this is pretty straightforward. The problem is that if I look at synchronous is great if I cannot tolerate any data loss whatsoever. But again, as you start to scale up and you start to look at 1,000, 2,000, 5,000 VMs in your environment, synchronous isn't going to cut it because unless you're Verizon, right, or AT&T, you probably don't have that much bandwidth between your data centers. So at that point, you start to look at other solutions. Now, array-based asynchronous looks attractive. Asynchronous, however, has one drawback, which is that if you're writing a database, for example, and you're writing the same blocks over and over and over again, right, what will end up happening is you'll actually send a lot of data over wire that doesn't need to be sent. If you use something like a periodic snapshot or periodic replication, what we do is we actually look at, or the technology will look at the differences at any given point in time. You can choose your RPO. Let's say it's 15 minutes or 30 minutes or 45 minutes. And every 45 minutes, it'll take a snapshot, look at the differences, and then send those differences. Even if I rewrote the same data over and over and over again, that has no bearing on the replication because I'm only going to send the block once. So it reduces my I/O, throttles my I/O down significantly. And as I choose my RPO, I may choose an RPO of 30 minutes or 45 minutes, and I can let it trickle. And so the amount of bandwidth that's used is significantly lower. And that's probably why, when we look at what VMware is doing with their host-based replication for SRM, they're choosing the periodic method. Because for large environments, the periodic method is really the only way to go. Unless you have really mission-critical applications, then you're starting to look at the asynchronous and synchronous depending on how much data you can lose. Okay? So again, host-based solutions can provide any of these. Quick time check. So the last thing I want to talk about is desktop virtualization. Desktop virtualization is obviously a hot thing. Vue 4.5 released today, or was announced today. Why desktop virtualization? Well, again, there's 2 reasons. One is around simplified IT management and reduced cost for desktop environments. The second one is around security and compliance. So with desktop virtualization, we can reduce the number of PC images. We can manage them all centrally. From a security perspective, we can secure them centrally as well. So from a compliance perspective, we can make sure that they comply to specific rules. from an antivirus perspective, we can actually do antivirus from a centralized location. So as you look at storage solutions for doing virtual desktop, what you really like to look at is storage solutions that can integrate well with an antivirus solution that can actually read the VMDK images themselves, so the virtual machine images themselves, and actually provide antivirus services directly from the storage solution itself. You don't want to be running your antivirus directly in the guest, okay? Because as you start to scale up, that becomes a very expensive proposition in terms of the amount of CPU that you're using across your infrastructure, right? Data loss prevention also becomes possible. So if we centralize our desktops, and we want to make sure that, number one, data is not leaking out of the environment, and number two, that desktops are only allowed to come up on devices which are or meet certain regulatory or compliance requirements. And we heard an interesting anecdote at a previous session. Large government organization needs to scan. It's actually the patent organization. They were not able to process patents fast enough. They needed to hire an additional 3,000 processors, but they don't want to move 3,000 people into Washington, D.C. Instead, what they do is they actually have 3,000 people scattered throughout the country with the ability to launch their virtual desktops on their own PCs, but we can actually control that those desktops can only come up on those PCs which are approved by the patent agency. So the question is, in a virtual desktop environment, and how many of you are using virtual desktops today? Just one? How many considering it going forward? Okay. So what are some of the problems that you think about? What are the key challenges that you face in virtual desktop? What are the things that they make you worried? Resources. What kind of resources? So basically, how many hosts am I going to need? Is that it? Okay. Storage, okay. Storage resources, okay. Disk I/O. How much I/O is it going to produce, right? So what? Correct. So offloading as much as possible to the array or to the storage solution. So provisioning is one of the things that come up most commonly. How am I actually going to provision additional VDI? Meeting SLAs. So am I going to get the performance out of the VDI that I want? So I'm not going to suffer the boot storm problem. Am I going to suffer this antivirus storm problem? How am I going to manage it all? So who's going to manage this environment? And lastly, what's it going to cost? So what's the cost per VDI? And cost per VDI is actually the primary concern that we come up against. And a good chunk of the actual VDI cost actually comes from storage. Okay? So we are actually announcing a solution called Virtual Store. It'll be in the next slide. Symantec is announcing it in November that solves the cost per VDI from the storage perspective. Okay? To reduce costs, we talked earlier about how NAS-based solutions can offer things like deduplication, integrated backup, can leverage thin provisioning in order to reduce the storage cost per VDI. From a streamlining operations perspective, if we can do things like cloning, if we can provide centralized management of provisioning new virtual desktops, all of these things can actually help make deploying virtual desktops easier. So traditional NAS filers help. So if you look at some of the traditional NAS filers that are out there, they integrate pretty well in terms of providing virtual desktop infrastructure. The problem is, as I mentioned earlier, for a small number of virtual desktops, that whole question of my resources, what's it going to cost me to do this, becomes a big problem. Because if you look at a $70,000 filer providing 50 virtual desktops, it just doesn't make sense. On the other hand, for really large environments, looking at the thousands, we have a problem where we start to saturate our infrastructure. From a storage perspective, if I'm saturating a filer, I'm buying additional filers, or I'm putting more hardware into that filers to accelerate it. Even doing that, you'll be maxed out at some point. It becomes pretty expensive to manage and also to own, cost of ownership. So the solution that Symantec has got for this problem is called Virtual Store. What is Virtual Store? Virtual Store says a lot of our customers, a lot of our end users are using SAN today. So we talked earlier, and John's using Symmetrix in his data center today. They want to continue using Symmetrix, but they want to get the benefits of NAS for VDI environments, or even for their VMware server environments. They want to get the deduplication, compression, the thin provisioning enhancements. but they want to put NAS in front of it. Now, they don't want to go and buy NAS filers, or maybe you do want to go and buy NAS filers, but I bet you probably don't. You're looking at it. An alternative solution is to use the SAN that you already have today, use the Symmetrics, and actually have a converter that converts the SAN environment into a NAS environment. And that converter is Virtual Store. Virtual Store is, if you think about it, it's like a soft appliance, a software appliance that runs on Linux boxes, cheap commodity x86 boxes, consumes SAN on the back end, and spits out NAS on the front end. Allows you to reduce your storage spend through deduplication and cloning. 70 to 80% of your storage goes away. Now, when you talk to guys like NetApp, they'll say, look, we can guarantee you 50% less storage than anyone else. Well, first of all, I don't know how they can guarantee that because we're basically doing the same thing they are, the same compression ratios. But it's not the storage that's going to end up costing you a whole lot of money for your environment. A 10 gig OS image won't cost you more than $30 from a storage perspective. But if you think about what the controllers cost, if a NAS controller for a FAS 30 series or 60 series NetApp filer is costing you about $30K to $40K, right? And you think about the number of VMs you have on that, the majority of your cost is actually coming from the controllers. So if we can eliminate the controllers completely, keep the storage that you have today, and shift the cost to low-cost Linux boxes running this soft appliance, you now have a solution which replaces NAS controllers with Linux boxes. They're kept highly available, and they scale. How big do they scale? They scale to 32 servers. So you can put 32 blades or 32 Linux boxes, back-ended by your existing SAN, front-ended with NFS, 1 gig or 10 gig links, depending on what your performance needs are. And with 1 gig links, we're able to see something on the order of 1,000 VDI, probably about 250 virtual servers per Linux box. Now, since we scaled to 32 of these Linux boxes, we're looking at scaling well beyond actually what the capabilities of vCenter are. vCenter can host 10,000 VMs per vCenter. Well, we can do upwards of 30,000 in a fully loaded cluster. Okay? So if you look at this solution, would you rather have 10 Linux boxes serving out your 10,000 VMs at a cost of, what, $5,000 for a Linux box plus the cost of the software? Or would you rather have 10 NetApp filers at a cost of $70K a pop in your data center? It's pretty simple economics. Okay? Sorry, it looks like you had a question. No? Okay, that's fine. So I'm actually wrapping up. So one thing I wanted to call out is that we have the Symantec Connect website. You know, as I mentioned, I'll give away 2 of these things. It's like looks like the last 2 people in the room will get these 2. You go to the Symantec Connect website, sign up. You can find all sorts of information about these products that we've talked about, as well as our other products from Symantec. But sorry, go ahead. Question.
My question is basically a rehash of the application availability product that you had.
Yeah.
You need to install an agent on the ESX host?
Not on the ESX host.
On the vCenter server?
There is first a plugin that you install. Just like with SRM, you'll have an SRM server. You'll have a application HA server. It could be a virtual machine. And then the agent actually gets installed directly into the virtual machine. That agent is installed in the virtual machine. It monitors the application inside the virtual machine, and it heartbeats down to ESX.
Okay, and how, you said you didn't need a standby or secondary VM
Correct.
online?
You don't need one.
So if the operating system crashes or the applications that Exchange 2010 itself crashes, how is this rebuilt so that you get up and running?
So if let's say Exchange 2010 crashes, you can attempt to restart the agent may attempt to restart Exchange 1 or 2 times, depending on how you configured it. If it cannot restart it, it'll essentially fail to heartbeat down to ESX, which indicates to ESX to VMware HA that it's time to actually restart the virtual machine. So it'll consider it like a virtual machine failure. It'll tear down the entire virtual machine. VMware HA does this, and it brings it back up. Depending on the policies you've set, you may actually have it move to another ESX host. So it integrates with VMware HA. It uses the exact same policies as VMware HA. What it's doing is it's emulating a virtual machine failure. So it's telling VMware HA, for all intents and purposes, this virtual machine is no longer alive. And that's how it actually, it's through a recycling, a reboot of the virtual machine. If you can tolerate the downtime that a reboot takes, it's a great solution because it doesn't require standby VMs. Okay? SharePoint 2010, I believe, is supported, yeah, in the original. Not yet? It's not in the GA, okay. Thanks. I thought I saw it. Any other question? For App HA, Application HA? Okay. That's good feedback, so we should probably flush that out. Mm-hmm. Okay. Okay. Great. All right, well, thanks, folks.